You tech tick. Okay, welcome to the next section, which is about the area ratio and the rule that goes with it. This rule is more detailed than the aspect ratio rule and gets us closer to the nitty-gritty of what's really going on in those apertures. So let's define the area ratio. In words, the area ratio is the printed area of the pad divided by the total area of the aperture walls. In the figures below, you can see the stencil aperture walls and the pad that goes with it. The aperture dimensions of length, width, and thickness will determine the total area of aperture walls. And the printed area of the pad is determined by the same length and width of the aperture, since the only printed part of the pad is that exposed to the stencil aperture. Now we're going to be calculating the area of a printed pad. The area of the printed pad, APP, is equal to the two-dimensional area of the stencil. More specifically, APP is equal to the length of the aperture times the width of the aperture. The aperture determining the amount of pad that is printed. Next, we need to calculate the area of the stencil aperture walls. We'll call that AAW, and it's equal to the sum of 4 separate rectangles. This can be seen by cutting the corners of the aperture to reveal the inner surface of each of the 4 rectangular sides. So let's take a look at each of the 4 rectangular sides. The area of the first rectangle is equal to the width times the thickness of the aperture, and so is the area of rectangle 3. Now the area of rectangles 2 and 4 are equal to the length times the thickness of the aperture. The area of the aperture walls is equal to the sum of all 4 of these rectangles. That gives us 2 times WT and 2 times LT. Pulling the 2T outside gives the area of the aperture walls as 2T times W plus L. Time to meet the first objective. Describe the area ratio rule in words. This divided by that. How do we use the area ratio rule? The area ratio is equal to the area of the printed pad divided by the area of the aperture walls, which in turn is equal to WL divided by 2 times the stencil thickness, T, times W plus L. The area ratio rule states that the area ratio should be greater than 0.66. Okay, now that we know the ratio and the rule, how do we use it? If the area ratio is less than 2/3, then you should seriously consider decreasing the stencil thickness. Time to meet another objective. Describe the area ratio rule in equation form. So let's give it a try. Here's an example. Given the aperture dimensions of T equal to 6 mil, L equal to 0.5 millimeters, and W equal to 0.4 millimeters, and a printed pad area equal to L times W, we want to calculate the area ratio and then apply the area ratio rule. First, we need to convert the thickness T from mils to millimeters, so that the units used in the area ratio are all the same. This is very important. Next, we calculate the area ratio by dividing the area of the printed pad by the area of the aperture wall. This equal to W times L divided by 2T times W plus L, and gives the following numbers based on the diagram above and the converted thickness. 0.4 times 0.5 divided by 2 times 0.1524 times 0.4 plus 0.5. That gives a numerator of 0.2 divided by a denominator of 0.274 for a final result of 0.73. And 0.73 is greater than 0.66, so this aperture passes the area ratio rule. Here's the last objective for this section. If you can get this one, then you've got it down. Given these aperture dimensions, T equal to 5 mil, L equal to 0.3 millimeter, and W equal to 0.27 millimeters, and pad dimensions of the same L and W. Apply the area ratio rule and recommend a change if needed.